Okay, are we ready? Okay, so we're going to do radical equals a radical first. That's what we did last class. And remember, what's the difference when you solve these? You have to square them to get your linear equation, and then you go from there. So that's the first step, is to get rid of the radical, square it. But what that does is potentially gives you an answer that won't work. So at the very end, we have to check our answer. So that's the difference. You square it to get rid of the square root, and then you solve it as normal. But we have to check our answer because it might give us an answer that doesn't work. So square both sides. That gets rid of the radicals. And then we just solve as usual. So 3x, bring the 2x over, becomes plus. 11 is on the right, bring the 4 over, it becomes a positive. So x is 3. So we say, okay, good, but we have to check and make sure that that gives you positive under the radical, not a negative under the radical. So we have to check that it works. So we're going to check x equals 3 into the original equation. So in the original equation, we have 3x minus 4. So 3, remember I said remove the x, put a bracket. And then in the bracket, put whatever your answer is. So we're going to plug 3 in here, and I think it's going to work. This will give us 9 minus 4 is 5. This one gives us 11 minus 6 is 5. So they work. Both sides are equal. Yep.
Where do you have to figure out what square, it doesn't be like, rewriting that 3x minus 4, wouldn't it be then 9x minus 15?
No, because you're squaring a square root. Remember, a square root is a half power. And one thing you can never do when there's two terms in a bracket, we said this in exponents, you can never, ever, ever put the exponent on both pieces. That's not allowed. You can only do that if they're multiplied inside. Now, if we square that, and then what you're doing is 1/2 times 2. 1/2 times 2 is 2 over 2, which is 1. So it's just 3x. They cancel each other out. When you square a square root, it cancels out. It's a half power and a squared. The square root and the square cancel out, and you just have that. Yep. Sure. Yeah. I'm sure one of these works that way, and if not, I'll make one up. Okay, so you could also have like a fraction under the radical. Same idea though. We have one radical sign on one side, we square both sides. What's 1 squared? What do I do here? Square root and a squared cancel, so that is just whatever's under the root, and this is 1 squared, which is 1. So now, how do we solve that? We've got a fraction equals a number, so we cross multiply. So you're going to multiply the x minus 3 up on the other side, which is just times 1. Okay, so what happens here? X to the other side, and what's going to happen? Yeah, so no x's is equal to minus 3. What does this mean when you get that situation? No solution. And you just stop. There's no solution. There's nothing to check because the x's canceled out. Okay. Okay, so that would be a no solution type. Okay, number 3. Okay, so this is the same type, a radical equals a radical, but it is, looks different. We've got 2 radicals subtracted and equals 0. In this section, anything that we do has to equal 0. In the next section, we're going to do another number, but you'd have to be able to factor if there's a number there, so you just won't see it here. So that will happen later. This will always be 0 in section 1.4. After we do factoring, we'll go back to these, and then we can put a number, and I'll show you how to solve that. Okay, so how do we solve this? We move 1 to the other side so that it's a radical equals a radical. So probably move the negative over to the other side. It was negative on the left, so move it over to the right and it becomes a positive. And now square both sides. So you can even just write it here. You don't need to write the step over again. So 5x plus 1 is equal to 3 minus x. So bring the x over and the 1. Two over 6. 1 over 3, right, reduce it. And now we need to check. So we're going to check x equals 1/3. If you missed reducing it, it's fine. Just your numbers will be bigger. It'll be harder to check. You'll have bigger numbers. Okay, so now we rewrite this, the original one, before moving it over. Always in the very, very first equation before you changed anything. Because if you changed it wrong, then you're checking your answer in the wrong thing. So you always want to go back to whatever the exact original equation was. So 5 times x plus 1 and 3 minus x. So I took the x's out and put a bracket. Put the 1/3 in. So what I have is 5 times 1/3, which is 5 over 3. And 3 minus 1/3. So 5 over 3 plus 1, we have to do a common denominator to add those together. So that's like a 1 over 1. What would be the common denominator? 3. So we need to multiply the top and bottom by 3. So 5 over 3 plus 3 over 3. And what about this second one? This is over 1. So we need them both to be the same. So multiply the first one by 3. 3 times 3. 3 times 3. 3 squared. 3 squared. 3 squared is 9. 3 times 3 is 9. Half of you put 6 on the test. Half. I counted them. 3 squared is 6. Half of you. You probably don't even know if you did it or not, but you can look when you get your test back. But half of you did it. 3 times 3 is 9. So here, how do we join those together? There's a common denominator. So 5 plus 3 is on top, that's 8. 9 minus 1 is on top, that's 8. So is that going to equal 0? Yeah, the same number, root 8 over 3 minus root 8 over 3, you're subtracting the same thing, it's 0. So you don't need to go further, that's obviously 0. Okay, so it worked. Questions? No questions? 3 squared? 100 minus 75. Yeah, some people got that wrong. Not very many, though. It's just sad when I see mistakes that, like, make the question wrong, that are silly, right? And then you lose marks. If you lose 1 mark in every question for a silly thing, you end up with 50%. All right. So what did I change here? How is this one different? The 2 in front. So that needs to be squared as well when you square both sides. So when we square both sides here, you're going to square that, and you're going to square that whole side. So not just the radical. So what do we end up with when we square it? This one will cancel because it is just a radical. So minus 3x plus 7. What about this side? What do we do with that squared? So the rule when we have a bracket squared with 2 things that are multiplied is you square both. So we would square the 2 and then square. So we have 2 squared is 4 times x plus 4. And make sure that's in a bracket because that 4 is times the whole thing, not just times the x. And now we can solve. 4x and 4 times 4, 16. Minus 7x equals 9. Now, a negative answer is okay. You have to check it to make sure that it works. It might not be okay when we plug it in, but actually I think it will be fine. Now, why did I rewrite that? Because it's weird to leave the negative on the bottom. You always put it on top, okay? Questions about that so far? So what are we going to do next? Check. And you can always check your solutions in these for every question, but you have to check the ones that have a radical in the beginning, okay? And a log as well, but we're not doing log yet. So the original question. So I'm going to check. The original, before we changed it, before we squared it, take out the x's. And in their place, put the answer that we're checking, 9 over 7, minus 9 over 7. Okay, so here's a fraction times a fraction. That's like a 3 over 1. 9 times 3, 27 over 7. 1 times 7. Okay, so common denominator. This is like over 1, so we want it to be over 7, so multiply by 7 over 7. 7 times 7 is 49. 49 plus 27. Without adding this, what would be a strategy to add these two numbers without actually lining them up like I'm doing and adding them? This is like 50 plus 27, what would that be? 77, but it's 1 less, so 76, because it was 1 less than 50. All right, and the other side, that's like a 4 over 1, so multiply by 7 over 7. This is minus 9 plus 27. Or plus 28, or 28 minus 9 is the same thing. You're subtracting the 9, adding the 28. So what's that equal? 19. All right, so how are we going to check that those are equal? No, you don't want to square it. That's getting rid of stuff. You want to simplify this radical to be here. How would we bring a 2 out of a radical or bring a 2 into a radical? We can square the 2 and bring it in, or we can factor the 47, it must be 4 times something, and bring that out. Or the 76, I don't want to say 47. Okay, so if we square this, it goes under the radical, right? Because 2 squared is 4, and the square root of 4 is 2. So 4 times 19 over 7. 19 times 4 is 80 times 4 minus 4 is 76. Now, I've done 2 like that in class. That's hints when people say that, right? Okay, the next one. Okay, so 5 and, was that number 4? Yeah, so 5 and 6 are very similar. I'm going to write the 2 questions down and then we'll solve one at a time, okay? So question 5, I want to put them side by side so we can look at what the difference is before we do the answer. So they're very similar. Okay, what's the difference? What's the difference? Can you see the difference? They're not the same. The square root signs are different. This one is over the whole fraction, and this is over each piece individually. You'll end up with the same answer, because once we get rid of the square root, we'll get the same answer. But one of them is going to be inadmissible and one of them is not, and I'll show you why when we solve them, okay? This won't always happen. I had to, try hard to get a question that works this way, okay? So it doesn't always happen, but I want you to see the difference, because there's a subtle difference. Did any of you not see the difference when you first looked at them? Couple people? There might be one like that on the assignment. 2 that are side by... Oh, I did put that on there. All right. So let's solve the 2, okay? So I'm just going to go to a new sheet. So we're going to do 5. Oh, are they? Okay, so we'll solve this. So it's a radical on one side, so we square both sides. When you square 2, what do you get? 4. So make sure you square both sides. Don't just rewrite both sides without the radical sign. Okay, you have to make sure you square both sides. So that number on the other side does change if when you square it, if it didn't already have a radical. Now, how do we solve this? Cross multiply. So that 3x plus 4 goes to the top of the other side. And expand that. Make sure you multiply it by both. (2x minus 12x equals 16 plus 4). Negative 2. And if you have a hard time reducing fractions, remember, here you could say, well, they both can divide by 10, so you could take that off. You'd have negative 2 over 1. You never leave a 1 on the bottom in your final answer, because that you don't ever divide by 1. So You don't write, like, you don't put a 1 underneath that. Rewrite it without the 1, okay? So, there's our answer. Now, I'm going to check that in a minute, but what about number 6? What happens when we do that? We'll just do it side by side, because when I square both sides, so here you could square this side and square that side. The rule with exponents and fractions, if you square a fraction, you square the top and you square the bottom. So this works out to be, squaring the top is 2x minus 4, squaring the bottom is 3x plus 4. 2 squared is 4. That's the same question now. It doesn't look any different than what we had on the other side once we square it. So when we solve this, what's our answer going to be? -2. So what the difference is the -2 will work in one of them and will not work in the other one. Okay, so I'll show you how that's possible. So if we were to check, so take number 5. So checking number 5, take out all the x's, and in their place we're checking x is -2, so plug -2 in here and here, and then work it out. So, -2 times 2 is -4. 3 times 2 is 6, -6. -4 minus 4, -8. -6 plus 4 is -2. Minus over minus, plus, and 8 divided by 2 is 4. So that one worked. So why is the other one not going to work? There's going to be a negative under both square roots because the second one started this way. And when we put the -2 in, on the top we're going to have -4 minus 4, and on the bottom -6 plus 2. So for number 5, it worked. And that's because we had it all under the radical, and when we simplified it, it was a positive under the one radical sign was a positive. This one, under the radical sign, we have negative. And it doesn't work because you can't have a negative under the root. Okay, so you have to be careful where that original root is, and you always go to the original question. Don't check it in any step after the very start. Because something subtle like putting 2 radicals instead of just 1 can make the difference with something working or not working. Questions? Okay, so I guess there is a set of those on the homework. Does anyone still need that? Okay, so what about this one? Any ideas before we start? You can still square both sides. So what you may or may not realize, but that whenever you do a square root on your calculator, the answers are always positive. And this is saying we want a radical to equal negative, and it can't because you're always having something squared. Take the square root of it. So this is not possible right before you start. But what if you didn't notice that? Because I know most of you wouldn't sort of say, oh, this question's not even possible to begin with. You'd go through and solve it, and what's going to happen with our answer? It won't work. So let's do it and see. So you don't need to solve this one at all, and you should write that down. Don't need to solve. Why not? Since a root can't equal a negative number. It can't. So you would just say, oh, this is not possible. There's no solution. But let's go through and solve, pretending like we didn't notice that. Okay? So if you square both sides, we get 2x minus 3 is equal to minus 2 squared, 4, positive 4. And now it'll work, because it's okay, we got rid of the negative. But when we get our answer, it won't work in the original. So 2x equals 4 plus 3. Don't write a mixed number, 7 over 2. Good practice with fractions. So we'll check. So we want to check x is 7 over 2. Writing down the original equation, just taking out the x's. And put 7 over 2 in here. Okay, cool, this is a good one. What's 2 times 7 over 2? Okay, that's one, it's true, 14 over 2, but I said it's a good one because I'm not going to do it the normal way. What am I going to do? Cancel the 2. I said always look for that first. You might have forgot that I said that, but this is like a big fraction, 2 times 7, and there's a 2 on top and bottom. So this is actually 7 minus 3, which is 4, and root 4 is not negative 2, right? And because we squared it, we kind of made it work for a positive 2 because we squared it, but the original question had the negative, so it won't work. Does that make sense? So even though you do get an answer, you need to, when you check it, you'll realize that that didn't actually work. So what do we say when it doesn't work? No solution. We can say x is 7 over 2 is inadmissible. There is no solution. Right, because this, 2 times 7 over 2 is 2 times 7 over 2. Yeah, and that's the definition of canceling, right? If you multiplied it, you'd get 14 over 2. And then to simplify, we'd say, well, 14 is 2 times 7, and we can cancel that, yeah. Right? So if it's already factored, you cancel before multiplying it. Yeah. The inadmissible part? Or the check? The check, you have to show, always, when there's a radical. How you write your solution, if you check and it doesn't work and you write no solution, that's okay. Yeah. But what's going to happen later, and that's, I said this last class, why I'm writing inadmissible is because in the next section when we go back to these, you're going to end up with 2 or 3 answers. Some of them are inadmissible and some of them work, and then it asks, determine the admissible and inadmissible solutions. Right? So the ones that don't work are called inadmissible. So I'm just calling them that here so that later it'll make sense. Some of them are admissible or work, and some of them are not. Okay? In these particular questions, this first one, we don't have to do any factoring, so we're only doing questions that work nice with one answer. after, when we do factoring, you'll end up with 2 answers, or 3. And then some will work, you have to check them all, each of them. Some will work and some won't work. Okay, what about this? Is it okay for a square root to equal 0? Yes, just not negative. It can be 0 or a positive number, just not negative. So we do the same thing. We just square both sides. 0 squared is 0. So x equals 3. Okay, I just put a simple one, not much to do, but just to illustrate that it can be 0, that's fine, that's a perfectly acceptable answer. There are answers that don't work, like no solution, and this is, being 0 is fine, okay? Or the answer could be 0 too, like this next one. So we just square both sides. So that'll give us 3x equals 4x, which kind of looks like it doesn't work, but it's still okay. If you move the 4x over, you have nothing left over here, so 0. How did I get from minus x equals 0 to x equals 0? Yeah, you could divide by -1 or switch all the signs. Oops. Divide by -1. Ugh. 0 divided by anything is 0. Okay. It's not undefined, which some people put on the test when the answer is 0. It's not. That doesn't mean undefined. What's undefined? Yeah, when the 0's on the bottom, you can't do that. 0 on top is totally okay. Okay, so that's it for that section. So the next section is 1.5, and we'll start that. Okay, so you should be able to do all that homework tonight. My office hours are this afternoon, and I'm also around tomorrow morning. And if you need help, and the help center's open as well. Okay, so
2 to 8.
2 to 8, the help center's open. Yeah. Okay, so section 1.5 is absolute values and inequalities. Use these a lot in calculus. So we're going to just start with absolute values today. Okay, so does anyone know what an absolute value is? Yeah? Excellent. Anyone else? Because you probably didn't hear them, so let's have a couple more guesses. No. Anyone else? Absolute value. What's it mean, or what do you do? Yeah? Yeah, and what's magnitude mean? Do you know? Okay, so magnitude actually means length, and that's right. Okay, but is anyone here taking linear algebra? Yeah, a few people. So you might have heard that word in terms of vectors. The magnitude of a vector is the length of a vector. Okay, So we've got two different, what he said is this, it's the distance from 0, and you kind of said that, but in a different way. You said whatever the number is, make it positive, right? And they're both okay. The absolute value is the distance from the origin. Now, the origin might not be 0. So that's going to be confusing. All right. And when it's not 0, I'm going to call it the center. Okay, and you can call it the center too if you want. But I'm just giving it a separate name because we'll use the word center for lots of different things, and it's sort of like your starting point, okay? So you could call it starting point as well if you want. So that being said, yeah, if we say the absolute value of -3, it is equal to 3. You do just take the length or the magnitude of the number or the number itself without the sign, okay? So you do, it is true. And the absolute value of 3 is also 3. So one thing is that it's a distance, and distance is always positive, so the answer has to be positive, and that's why you can do that. Here's 0 on a number line, and let's say -3 is here. So it's 1, 2, 3 is the distance away from 0. And 3, positive 3 is also 3 away from 0. Okay, so they're both equal to positive 3 because they are 3 away from the origin. Okay, so this isn't how we're going to see absolute value. We're going to see it with some variables in there. So I'll show you. So say we have the absolute value of x is equal to 6. So what is this saying? Right, y positive or -6. This is saying what number on the number line is 6 away from 0. Or the origin. So what that's what that equation says. The absolute value of 6 of x equals 6 says, solve for x. What value of x is 6 away from 0? And so what answers are 6 away from 0? Here's 0. Both sides are 6 away from 0, right? So we have two possible answers. 1, 2, 3, 4, 5, 6. So we would say that x can equal -6, or 1, 2, 3, 4, 5, 6, x can equal +6. Two possible answers. What about this? So let's say that's example. That one. What values of x are a distance -2 away from 0? There's no such thing. You can't have a distance -2. There is no -2 on a ruler. You can't go up and measure -2 units away from something. So there's no solution. I can put a 2 in here, but I would get a 2 as the answer. I could put a negative 2 in here, but I would get a 2 as the answer. You can only have positive. And there's, unlike the radical where you can accidentally solve it, if you do that here, you'll have the wrong answer. Okay, so there's nothing to solve. You can't do it. And later I'll accidentally solve one and show you what happens. Okay, but there's no solution. Why? Did you write down why? So when you look back at this in December, you'll remember why there was no solution? Because the distance can't be negative. No absolute value can equal a negative. So you should write that down, and you'll wonder, why did I write that, no solution, and not do anything? What about this one? Yeah, 0. 0 is 0 away. Nothing to solve. 0 is 0. So these are the possible answers. You can get 2 answers. You can get no answer, or you can get 1 answer. That's 1, 2, or not 1, 2, or 3. 0, 1, or 2 possible answers. No answer, 1, or 2. When you did graphing in high school, do you remember what the shape of an absolute value is? Anyone remember? It looks like, no. That is if it has a squared under a radical. Looks like that, but
Is it like a V shape?
it's a V shape. Okay? And we'll see that in chapter 2, the graph. So you don't really need to know the graph here, but it kind of helps us to understand, like, if it goes like this, it crosses twice, 2 answers. That's what you're finding, is those 2 answers. If it doesn't cross, where would the V be? No, because to the left or right would still cross twice. Right, it would have to be up here somewhere. And see, it doesn't cross this line. When we solve for x, we're solving for the number line. That's this horizontal line. So if that graph is up, there'd be no answer. And what about 0? How could we get 1 answer? It touches it, just the tip touches it. So this would be no solution. This has 2 solutions. So does this. And 1 solution is if it touches that line, right? But it doesn't go twice, so that would be 1 solution. Okay. So that's the 3 types of solutions. So what was I talking about? The origin not being 0, and that is for this type. And this is, we'll do a couple examples of this, and then we'll be done. Okay, so the difference is if there is anything in that absolute value other than just an x. Okay, so we've got an expression in there that's not just an x. That's when the origin is not 0. So when we had this, x equals 0 is what we're talking about, the distance from 0. Okay, for these, if there's something else in there, you say x plus 3 equals 0 gives me x is negative 3 is the center. So if we were to draw this on a number line, instead of being centered at 0, we're centered right here at negative 3. It's whatever makes that 0 inside that bracket. So if we're centered here, what's this question asking? What numbers are distance of 4 away from negative 3? That's what the question is asking. What value of x are 4 away from negative 3. So what are the two answers? 1, 2, 3, 4. 1, 2, 3, 4. So we'd say the solution is that x is negative 7 or x is positive 1. So what happens when you plug these into the original? So if I want to check negative 7, I get, so I plug the negative 7 in for x, I get negative 4, because minus 7 plus 3 is negative 4, and the absolute value of negative 4 is 4. So it worked. That one was our negative, right? See, we went in the negative direction for. That was our negative one. And then what should the other one give us? It'll give us the positive side. So x is 1 if we plug that in. We get the positive. Okay, now with all that being said, you don't really need to find the center, although it's a useful technique, especially when we get to graphing, is to know where the tip of the V is at negative 3. That's where that V is centered, is whatever makes the inside of that bracket equal 0. That's where the V is centered. So it will be useful to find the center, but you don't really need it to solve this equation. To solve x plus 3 equals 4, you can say, okay, we want a distance of 4, so this either has to be a 4 inside that bracket, like this. Right, that had a 4 inside the bracket, so we could say x plus 3 has to be 4, and then solve it. That would give us 1. So just say, okay, well the inside of the bracket has to be 4, or what? The inside of the bracket could be, the inside could be negative 4, so we would say x plus 3 equals negative 4, and we would get negative 7. So we can get the two answers by just saying, okay, well the inside has to be either positive 4 or negative 4, solve those two equations and we get it without finding the center. Okay? So yeah, you can do that here every single time. However, when we get to graphing, we're going to look for that center because that gives us where the point of the V is when we're drawing it. So we'll want to go back and look at that later. Okay, so we'll do more absolute values next class, so obviously adding more complication to it, but you don't need to do that section for this week.